Today we're looking at symbolic logic, a part of our Introduction to Logic course. Statements can be considered atomic or compound statements. Atomic statements simply mean it's a simple statement that does not contain or refer to any other statement as a component. Example, Sinead is neat. A compound statement, however, contains another statement as a part of the statement. For example, Sinead is neat and Rishanda is sweet. So we're going to be working on our connectives. And the 5 that we'll be covering are the conjunction, which is and, symbolized by the dot. The disjunction, which is or, either or. And we're using the inclusive version of the disjunction. So you may read up on what is the inclusive versus the exclusive version of the disjunction. But we're using or, and that's a V. Not, that's negation. Right? I think this is called a tilde. If then, conditional statement, we have the arrow, and we have our biconditional, which is if and only if, and we use a two-way arrow for that. So let's go, starting with the conjunction. The rules that govern a conjunction say that a conjunction is true if both conjuncts are true. So if both parts of the statement are true, if both atomic statements are true, then the overall conjunction is true. Otherwise, it is false. So we're going to be doing a truth table to test, to show how we symbolize conjunctions. There are some guidelines that we should follow. First, the number of rows that we use for the true or false is just 2 raised to the power of the number of atomic statements. So in this example, we have 2 atomic statements, A and B. So we are going to raise 2 to the power 2. And 2 raised to the power 2 will give us 4. So we have 4 rows for our true or false statements. 1, 2, 3, 4. Alright. Next, for the first column, we're going to split it half and half. The first half, that's the first 2 rows, will be true. And the second 2 rows, or the final 2 rows, will be false. So half true, half false. For the second column, we're going to alternate between true and false. So we're just going to have true, false, true, false. Now, when we do it like this, it shows all possible combinations of true and false for 2 atomic statements. So we'll now apply the rule. The rule says a conjunction is true if both conjuncts are true. So that means for it to be true, both A has to be true and B has to be true. Alright, an example of a conjunction as we use, Sinead is neat and Rishanda is sweet. So for this overall conjunction to be true, then both atomic statements must be true. So A must be true, B must be true. So in this case, if both of them are true, then the overall conjunction is true. In every other case, where both of them are not true, the conjunction is considered false. So this would be a truth table representing a conjunction. Next, the disjunction. The rule, a disjunction is always true except when both disjuncts are false. So here's our truth table. Again, guidelines. Number of rows for true or false, it's 4 rows. 2, there are 2 atomic statements, so it's 2 raised to the power 2. First column, similarly, half and half, true, false. Second column, alternate between true and false. So let's look at the rule. This is an example of a disjunction. Rachel is present, or there was an earthquake. So A would be Rachel is present, B would be there was an earthquake. So we say a disjunction is always true except when both disjuncts are false. So it means that for the overall disjunct to be false, both A and B must be false. So in every other case, the disjunct would be true. So as long as one part of the one atomic statement is true, then overall disjunction is true. If both of them are false, then the overall disjunction is false. Alright, so let's continue. Negation. So negation, the rule is the negation has the opposite truth value of the original statement. And it's our truth table. So this time around, it's only one atomic statement that we're using. So the number of rows is 2 raised to the power 1. So we only need 2 rows. And since it's just 2 rows, we just alternate. We just show true and we show false. So the rule says the negation is the opposite of the truth value for the original statement. Example, Holland High is in St. James. How do we negate that? We negate that by saying Holland High is not in St. James. So what we're saying is if the original statement is true, then the negation is false. So if Holland is really in St. James, if that is true, then it is false that Holland is not in St. James. Similarly, in this case, since Holland High is not in St. James, then the original statement is false, which means that the negation is true. So opposite truth value to the original statement. True, negation false. Original is false, negation is true. Next, our conditional statement. So a conditional statement is only false when the antecedent is true and the consequent is false. Antecedent is true, consequent false. So again, truth table is just 2 conditional statements, 2 atomic statements. So we just need 4 rows. Same rules. Now the rule for the conditional says a conditional statement is only false when the antecedent is true and the consequent is false. So the antecedent is the first part. For example, we say if Xavier gets 100% on the test, then Xavier will get $1,000. The antecedent A would be Xavier gets 100 on the test, and the consequent B would be Xavier will get $1,000. So we're saying for this conditional statement to be false, the antecedent A must be true and the consequent must have been proven false. So in this case, antecedent true, consequent true, it's true. Antecedent true, consequent false. This is a one scenario where the conditional statement is false. Antecedent is false. We don't have to go any further because for the conditional statement to be false, the antecedent must be true and the consequent must be false. So if the antecedent is false, then the conditional is considered true in both cases. Alright, so the rule, only false when the antecedent is true and the consequent is false. Alright, next, the biconditional. So a biconditional statement is only true when the antecedent and the consequent have the same truth value, which means it is false when they have different truth values. So let's go. Alright, same setup. So, an example, the class will do well if and only if everyone studies hard. So A would be the class will do well, and B would be everyone studies hard. So we're saying it is only true, the overall biconditional statement is only true when A and B have the same truth value. So if both of them are true, it is true. If one is true and one is false, false. If both of them are false, then it is true because they have the same truth value. So a biconditional only true when both the antecedent and the consequent have the same truth value. Alright, what about if we had to do a truth table with three atomic statements? Alright, so all of 3 atomic statements. A, B, C. Now, 3 atomic statements, so the number of rows will be 2 raised to the power 3, which gives us 8. So we need 1, 2, 3, 4, 5, 6, 7, 8 true or false rows. Right? Order. For the first column, first half, true. Second half, false. So we have 4 rows true. Then the other 4 rows, false. So half and half. For the second column, we alternate between 2 truths and 2 false. Right, so since we had 4 truths, 4 false, we go half of that. So 2 truths, 2 false, 2 truths, 2 false. Right, so that's second column. Now the last column, we just alternate again between true and false. So true, false, true, false, true, false, true, false. And this represents all possible combinations of true and false when there are 3 atomic statements. Alright, so lastly, how do we test validity when it comes to symbolic statements? So here we go. If you have a statement, if A, an argument, symbolic arguments. If the argument is if A then B, A, so not B. And we want to test the validity of this argument. So first we need to put it in symbolic form. So you know, for the conditional we use an arrow. So that means if A then B. Well, A is just by itself, so nothing to do there. And for not B, we symbolize like this. So we now have the argument in symbolic form. So we go to our truth table now. Right, so first we need our atomic statements, A, B, as we have been doing. Then we have columns for the premises and a final column for the conclusion. Alright, I will show the symbols in each case. So for the first column, you know it's half and half, so 2 truths, true, false, 2 false, 2 true, 2 false. Second column we alternate true, false, true, false. Then, rules now. So the conditional statement is only false when antecedent is true and consequent is false. So antecedent true, consequent true, true. Antecedent true, consequent false. That's the only scenario when the conditional statement is considered false. Antecedent false, we don't have to go further. Antecedent false, don't have to go any further. So the conditional only considered false when the antecedent is true and the consequent is false. Next, we have A. Nothing to do there. We just need to put the truth values for A. So whatever we had as the truth values for A, we just duplicate them. So we have true, true, false, false. Alright, so that's it. A, we just put back what the truth values are for A. But now we have not B. Negation. I would say it's the opposite of the truth value of the original statement. So the original statement is B. So when B is true, the negation is false. When B is false, negation is true. When B is true, negation is false. And when B is false, negation is true. And now we have our truth table completed. But we have to go a step further and analyze this truth table to see if the argument is valid or invalid. So let's remind ourselves. A valid argument is one where the conclusion must be true if the premises are true. Right? So the premises guarantee the conclusion. As long as all premises are true, the conclusion has to be true for a valid argument. So, step 1. We look for all the rows in the table where both premises, and if there are 3 premises, it will be all premises. Right? So we look for all the rows where all the premises are true. In this case, it's only the first row. Right? Both premises true. There are no other cases where both premises are true. Right? So that's step 1. Identify all the rows where both premises are true. Step 2. If the conclusion is false in that row, then it means the argument is invalid. Why? Because the conclusion must be true if the premises are true for a valid argument. So in this case, both premises are true, but we have a false conclusion. That tells us that this is an invalid argument. Alright, and this basically sums up what we need to cover for symbolic logic. All the best in your practicing, and that's it until next time.